Good morning, everyone. I'm Dr. Jyotsna. I will be talking about TEG interpretation, only about interpretation of the TEG. So this is a normal TEG graph, and it has got coagulation part and fibrinolysis part. Coagulation part has got R time, which is represented by a long tail, and it tells you about the time from the machine is start to the time of clot formation. So this takes generally 5 to 10 minutes, and if it is prolonged, suppose tail is big, then you have to think that there is a problem with the coagulation factor, and so we will have to give FFP, or if the patient is on anticoagulant, you may have to give anticoagulant reversal. And this you can see, this is the K time. K time is this from the starting of clot to uh, 20 mm of amplitude. So amplitude, the clot will start forming, and there will be a the amplitude will be measured. Once it reaches the 20 minute of 20 mm of amplitude, this distance is measured, and this is called K time. We don't have to measure, the machine will measure and tell you the K time. So normal K time, you can see it is 1 to 3 minutes, and if it is increased, means there is a problem with the fibrinogen level, there is a low fibrinogen level, then you will have to give cryoprecipitate. Now you can see this is the alpha angle. What is alpha angle? Alpha angle is the horizontal line from the mid and the speed of clot formation. This alpha angle tells you. So if suppose very quickly the clot is forming, then this alpha angle will increase, and if it's very slowly forming because of the any problem, the alpha angle will decrease. So if there is a decrease in alpha angle, you will have to again think that there is a problem with the fibrinogen level, hypocoagulable state, and you may have to give cryoprecipitate again. The normal angle is between 53 to 72. So if it is decreased, then you will have to give fibrinogen. Now same, this is the maximum amplitude. The maximum amplitude, this in the graph, the maximum amplitude is measured. The normal it is 50 to 70, and if the amplitude is low, means there is a problem with the platelet level or problem with the platelet function. So you can just remember a maximum amplitude, one over another you can put platelet, and that will form a amplitude. This maximum amplitude means there is a problem with the platelet, then you may have to give platelet, or you may have to think of, in 20% cases it could be because of the GP2B Y2 2B 3B inhibitor, like we give during the when the patient is suppose it's a MI patient or a CAD patient, or came for the stunting on GP2BY GP2B3A inhibitor is going on. So in that case also, this maximum MA angle will decrease. Or sometime, like if it is there is a uremia is going on, in that case also there could be platelet dysfunction. In that case, DDAVP may be required. So this is about the maximum amplitude. So from maximum amplitude, after 30 minutes, the amplitude, the height of the vertical amplitude is again measured, and it should be between 50 to sorry, it should decrease from 0 to 8%. So lysis at 30 minutes should is represented by percentage of the amplitude reduction from the maximum angle. You can see percentage of the amplitude reduction from the after 30 minutes, that is normally 0 to 8%. If this has increased, suppose this amplitude reduction has increased, it has come down to here, instead of it should be 0 to 8%. So there is a problem with fibrinolysis, there is excessive fibrinolysis going on, then we will have to give tranexamic acid or aminocapric acid. It could be in DIC patient may also have this such type of problem. So it will be depends upon the problem. according to the patient case we can identify, and this will exactly tells you about the which product you should give. The graph looks something like this. This is a normal person graph. So you can see this is the R, from here to here is the R time, from here to 20 mm of clot formation is the K time, and from this is the midline, and this is alpha angle. So alpha angle also is in normal limit, you can see. uh, and then this is the maximum angle. So maximum angle is 58, is the between normal level value will be also given, you can see. And so it is also normal. And now the lysis after 30-minute lysis should be 0 to 8% is 1.9%, so it is also normal. So this way, this is a normal person's graph, TEG graph. And generally you will get result in 40 to 45 minutes. So if there is an increase in R time, you will give FFP. If it is decrease in alpha angle, cryoprecipitate. If maximum amplitude is decreased, then platelet may be required, where you may consider for DDA VP according to the patient profile. If the fibrinolysis is going on, you have to give tranexamic acid or aminocaploic acid. This is just to remember. You can see this is normal. This is a normal TEG graph, and if you find this, there is a red wine type of graph, then red wine of type of graph, then you can think that you will have to give FFP. So you can see red wine type of graph means uh, this you can see this tail is big, you know. So tail is big means, see here also you can see the tail is big, and the amplitude, tail is big means R time has increased, and you can see the K time has also prolonged slowly. It is clot strength is increasing. 20 mm size clot is taking more time, that is K time has also increased. So the problem is with there could be some factor deficiency, so we'll give FFP. There could be, and patient may be on anticoagulant, or could be hemophilia or something like that. So in that case you will have to give FFP. So to remember, if the red wine type of glass is there, so graph is there, then you will have to give FFP. So in the same way, you can see brandy tumble. So this is brandy tumble is do nothing. This is called this brandy tumble, normal one. So if as a whole there is a tubular structure, so tubular structure, platelet is blocked, you know. There's a, so tubular structure you have to give platelet. If it is a, suppose if it is a maritime glass, you can see upside down of maritime glass, you have to give tranexamic acid. Means fibrinolysis is more going on. So you can see the you can this is the R time is normal. Maximum amplitude is continuously decreasing, and continuously decreasing, like in the continuously decreasing like this. And then there is a very fibrinolysis, the this LY30 is has increased. So this it is more than 8%. So it is because of fibrinolysis going on, because of the, it could be because of ये 2C plasminogen activator we have given, or streptokinase, ureokinase, or something like that. Because of that, suppose as a whole everything is like very big. This normal graph has just bigger graph has happened. Means there is a hypercoagulable stage. Maximum amplitude has increased. The MA has increased. You know, K time is shortened. And R is shortened. So in this hypercoagulable stage, with hypercoagulable stage, you can see there's more fibrinolysis is going on. So this is stage 1 of DIC. So hypercoagulable with secondary DIC, and this has a whole, you can see hypocoagulate. The tail has also increased. The FFP means the you will require FFP, means there is a coagulation factor deficiency, also there is a platelet deficiency, also there is a cryo, you will fibrinogen deficiency also. So DIC stage 2 as a whole hypocoagulable stage. So what is, you can see here, what you can see here, that the factor, this the R time has increased. The R time in this case and K time has increased, means R time increase means you have to give FFP and anticoagulant reversal, then K time will also decrease. Here in the case of thrombocytopenia, that you will see this is normal, but this is the K time, this is R time, this is normal, but you can see the maximum amplitude has decreased. So here it means platelet, the problem is with the either platelet dysfunction or platelet count. So here you can see the K time has increased. K time has increased and alpha angle has decreased. So problem is with the fibrinogen level. So we'll have to give cryoprecipitate. So here, so again, see maximum MA is, this is normal, MA has increased, but now suddenly very quickly decreasing. So fibrinolysis is going on. So maybe fibrinolytic we have given, maybe the patient has required something like that, maybe pulmonary embolism, and we have given thrombolytic, or maybe stroke, patient has stroke, we have given thrombolytic. So in that case, you will see LY30 will increase. And this is a high, you can see this is the hypocoagulable state, and R time has increased, K time has increased, MA has decreased, and alpha angle has decreased. So this is a hypocoagulable stage, as in DIC. So you have to give according to the patient condition here. So this is hypercoagulable state. Everything has maximum amplitude has increased. The K time is decreased. The R time is decreased. So here you can see R time is decreased, K time is decreased, alpha angle has increased, maximum amplitude has increased, and also the lysis at 30 minute has increased. So this is basically hypercoagulable state with primary fibrinolysis, as in DIC. So this was a patient, post-operative patient, which was bleeding from the wound after 3 days, and he had his infection. So we had to give blood component, and we wanted the result very quickly. At the same time, we don't wanted to give her more and more blood because she was in volume overload as well. So we did the TEG, and what is the TEG report? How we will interpret? Let's see. So the R time 2 to 8 is normal. It is 6.3. It is normal. Now what about the K time? So from beginning of the clot formation to the 20 mm of the clot's amplitude. So this is also 1.6 is normal range. Normal range is given there, and this is normal range. Now come to the alpha angle. Alpha angle, this from here and this. So this angle is made, and this angle is 67. So 55 to 78 is normal, and this is 60. So this is also normal. Now come to the maximum amplitude. So maximum amplitude is this, and this is 68. 51 to 69 is normal, so it is maximum amplitude is normal also. Now come to the 30 minute of lysis. 30 minute of lysis is 0 to 8 is normal, and this is 26. So more lysis is going on. So here what should we do? We should just give tranexamic acid or aminocaproic acid. So that we did. So here we have saved. The other we would have given FFP, and we would have given platelet. So here we have saved the blood component. We just had to give tranexamic acid. So this was another patient's TEG graph. Here you can see the R time. R time is 6.4, which is normal. And K time is 3, which is also normal. You can see it's a higher normal side, but it is normal. And then the yeah, alpha angle is 59, which is also normal. And maximum amplitude 44. This is in this is decreased. So maximum amplitude has decreased. Means what does it mean? Maximum amplitude means platelet. We need to give platelet. And what about the lysis? After 30 minutes, it has increased. So we also need to give tranexamic acid or aminocaproic acid. So here for this patient, we will require platelet transfusion, and as well as tranexamic acid should be given.